Question 1J, we're going to test this with our ratio test. So again, we're going to put an plus 1 over an and then check to see the limit of that. So putting the numerator, we end up with a negative 1 to the power n plus 2. And we end up with an n plus 1, which is plus 2, x to the power n plus 1. And in the denominator, we end up with a n plus 1 factorial. Okay, in the denominator of the main denominator, we end up with negative 1 to the n plus 1. Okay, those will simplify. We end up with n plus 1 over, x to the n over n factorial. Okay, so again, we're going to group some of these terms together. So the limit as n approaches infinity, okay, we're going to group these terms together. So we just have an extra negative 1 factor. So we'll write this as negative 1. Let's start with the denominator, the fraction here. So we're going to end up with negative 1. Okay, and then we're going to group together our n plus 2 and n plus 1. So we end up with n plus 2 over n plus 1, and we'll group those together. And we'll group the x's together. So we end up with x to the power n, and I'm going to write that extra x like that so we can cancel that out easily. And then from the denominator, an x to the power n, and we'll group those together. And then the factorials we can group together. So we end up with n factorial in the numerator, and then n plus 1 factorial, so n plus 1 times n factorial. Okay, so we can see that we have terms that are canceling here. The n factorials cancel here, the n cancel here. So at this point, I'm going to also apply my, well, before I apply the limit, let's simplify this. So we have the limit as n approaches infinity. That negative 1 really is not really significant. We have that n plus 2 over n plus 1. Well, that's going to become 1. We have our x, and we have all this. This is over an n plus 1. Okay, so that we've got grouped that together. We're going to put those together and we can evaluate this. We don't really need, we're not really putting those together, but the green becomes 1, and then as the limit of n plus 1 becomes, the denominator becomes infinite, okay, since the x value has to be finite, we know that this is going to be less than 1 for all real values. And maybe I'm just going to do it like this. So we have absolute value, negative 1. Again, that negative 1 is not really relevant. We have that becomes 1. And then for this term here, we have x over infinity. And we need that to be less than 1. And this will be true for all values of x. So our radius then is equal to infinity, and the domain is x is all real numbers, because regardless of what number we choose for x, the infinite limit of this is going to be less than 1.